is about the concept of load balancer, and I'm also going to be taking us through, how the project was executed, um, diverse technologies that was explored. All right. So, but then before I proceed, I would like to share a little bit of background concerning the concept of internet, how internet evolving, some similarities regarding the concept of load balancing and the idea behind it generally. So, first of all, why is scale unpredictable? Now, speaking about the business reality behind load balancing. So, when someone designs, or let me start by saying that every application software, that was ever designed or developed was for the major purpose of solving a problem or meeting a particular need. Now, the extent to which that software product goes in solving the problem can be at the initial level be envisaged or be envisioned, but the extent to which it will go specifically, no one can actually say. You can't actually, say categorically how it's going to scale over time. So and the same concept applies to internet. When internet evolved, internet protocol version 4, which is IPv4 at the time in 1981, I believe 4.3 billion IP addresses was initially provided, believing that it would be enough for the need at the time, because internet wasn't really prominent at the time. So 4.3 billion IPv4 addresses was available for internet users, and as time progressed, it became a problem because the IP addresses was not enough. People ran out of IP addresses, and majorly because advent of so many appliances, things that began to require internet protocol or IP addresses, like sensors, appliances, Internet of Things. So many devices coming up, and people began to understand that there is a need for something much more. Because IPv4 had at the time reached its limit. All right, and that was why there's something now called IPv6, which provides for 340 undecillion addresses. So this was actually designed to address the need or the problem that the limit of IPv4 clearly displayed at the time. And it's just going ahead to emphasize the same issue about the fact that the idea of how much something would scale is not necessarily what anybody knows from the start. All right, so I'll just proceed to my next slide, which is about what load balancer is literally. Load balancer sits between the client and a group of back-end servers, distributing incoming traffics across them dynamically. It acts as a traffic proxy and invisible facilitator that ensures no single server is overwhelmed. So the key idea, what I want to emphasize majorly on, is about the fact that modern applications handle huge, unpredictable traffic. I think I remember Ezekiel saying something last week about the fact that when softwares, or for example, like an e-commerce application during a particular time of the season or particular time of the year, for example, during say festive period, people have a need to go online because to use a particular website because of a discounted price to different things online. So such e-commerce platforms experience spike. They experience spike. What that means is that people get encouraged to visit that platform, visit that application or website, because of what is made available and what they are able to access. And so, if there is no proactiveness, if there is no vision to look ahead and say, this thing I'm building, this thing I'm working on can scale to a point where the initial users can get doubled, can be tripled in terms of the usage, in terms of how people adopt it and they begin to use it. And that's the that's the idea basically. So load balancer literally is a concept that has to do with the fact that when softwares when the need the need of software gets increased, when there is a hike, there is a spike in usage of software, a particular software, servers are needed. Servers in the background or behind the scenes are needed, to work together to manage the load efficiently, to manage the load, such that the software or the platform can serve the customers regardless of how many people they are, or regardless of the number of people that are using the platform. An example is Google. We have billions of people across the world who make use of Google, and no doubt there are thousands of servers that have been designed to support that platform, such that it can serve users dynamically at the same time. So availability, if one server goes down, traffic reroutes instantly. So when we have a number of servers that are companies or that are behind the scenes helping a particular platform to serve the need of customers or serve the need of users who visit the platform, which using our terminology, we translate to traffic, actually, traffic that is going into the platform. All right. If a server has an issue or a problem, what happens is load balancer instantly directs the traffic to another healthy server, a server that is healthy, that can receive the request and process the request, and then send back send back the answer, or whatever it is that the user needs at the time. Scalability, adding more servers behind the balancer to absorb traffic spikes. Yeah, I mentioned this when I was talking about the e-commerce platform, for example, especially during festive period, when people have to use a platform because of discounting their products and all that. Security, hide backend servers, spread attack surface, and then performance, distribute work evenly, minimizing lag. Yes, ensuring that one server is not overworked than the other. That's one of the importance of load balance, and ensuring that all the servers manage the load evenly. The load is spread across. It's just giving an example of distribution of labor in a particular family. Take, for example, you have 3 people or 4 children in the family, and there's a lot to do. The parents will say, okay, you do this, you do that, and just spreading the work evenly, just to ensure that one person doesn't feel like, oh, am I the house help? Am I the one who has to do all this work by myself? I mean, the whole idea is just about performance. I'll move on to the next slide. Horizontal versus vertical scaling. I really like this concept a lot, because I experienced it firsthand. So 2 ways to grow capacity when a server hits its limits. Horizontal scaling. I'll start by talking about vertical scaling actually, because vertical scaling talks about increasing the strength, increasing the capacity of a server to continue to function, to amplify its functionality, increasing the CPU, RAM, storage, and I'm going to speak about my experience from a particular project that we worked on. I think it's on the LAMP architecture. When I was trying to install PHP, though that has a different kind of context, but then I'll just speak about the experience that I got, or I had using that. So what happened was the PHP kept failing, and as I was trying to install, it kept failing, and I used an AI tool to troubleshoot and find out what the problem is. So I discovered that it had reached its limits. It had reached its resource limit at the time, and the only way to fix it at the time was, to increase the instance. So, of course, the instance was already created in AWS, right? And I accessed the instance using my local machine, VS Code particularly, and what I needed to do, I used the code at the time, and just to increase the CPU and the RAM, which expanded the capacity of the server on AWS. And immediately I did that, I tried installing PHP again, and then instantly it worked perfectly, it worked well. So, and that's the idea of vertical scaling. Vertical scaling is basically about increasing the capacity of a server to meet users' need. And then speaking about horizontal scaling, it's about load. It enables one server carrying all the load. Sorry, let me just read from here. This is what load balance. Okay, instead of one server carrying all the load, traffic is spread across multiple machines. Exactly. So horizontal scaling speaks to the fact that So when a server is overworked, right, has a lot of work already, horizontal scaling is adding more servers to bear that burden, so that the burden is not just on one particular server and it weakens the server such that the servers go down. So different servers has to, be added to enable the what's it called to enable the software to perform at its optimal level. Take for example, Google, I mentioned earlier, has thousands of servers, incorporated into the system to ensure that it's able to serve the need of users across the world, basically. Types of load balancer. So we have different types. I'll just run through this so I can speak extensively on the project architecture. So we have the hardware, a physical device with a specialized operating system, purpose built for balancing, usually very expensive. We have the software like Apache, Nginx. We are very much familiar with that. We have virtual, combines hardware and software approaches deployed. We have cloud-based, managed by a cloud provider, skills, blah blah blah. Yeah, I'll just move forward from there. To the next slide. So this is what our project architecture looked like. Executing the project using or just leveraging on the instructions that we got from our dashboard. So we have the client, the client, which can be the browser, all right, the browser that the individual is using to access the internet, and then we have the load balance, Apache in this case, routing traffic to the different web server. In my case, I used 2 web servers at the time, which was Red Hat Linux operating system, and then we have the database and the NFS server as well. So I'll move to the next slide now. So of course, before we got to the point where we executed the project on Apache Load Balancer, if you remember, we started working on the DevOps tooling website, where we had a lot of experience, hands-on experience, spinning so many servers, the NFS servers, the Red Hat Linux operating system, Ubuntu for MySQL database, and so the prerequisite here: 2 Red Hat web servers, 1 MySQL DB server. It's based on Ubuntu. Just to clarify a little bit, when I read a little bit about Linux, of course, Linux has different distributions, and I know we know that already. We have Ubuntu, Red Hat, we have Debian, we have all forms of different types of distributions, basically. So we also have 1 Red Hat NFS server, which is about sharing the storage, mounting the logs directory so that it can be in sync. All right, so I'll just move forward from there to the next slide. All right, so this step 1 has to do with provision and prepare the load balancer server. We used the Ubuntu operating system. We created an instance in AWS. I named it, for me particularly, I named it Apache LB. I opened port 80 in the security group inbound rules, and I installed Apache. So okay, sorry. So I know we're already familiar with the modules and why we needed to use all of these modules, just to enable Apache to serve or to perform, optimally as a load balancer. All right, so configuring the load balancer, I copied this code block from the dashboard and went into the configuration file, and then posted it there using the IP address from the instance created in the IP address of the 2 web servers, actually, and we have the first one, http // I don't know if I should just go through all of that, but I think we understand already. So just edited that configuration file so it can what's it called? So the configuration file can read the IP address, in serving the traffic, right? So I'll go to the next slide. So the next thing to do is, after editing the configuration file, the next thing is to restart Apache so that it can it can synchronize all of the informations that have been edited in the configuration file. All right, and then you access the load balancer using the load balancer public IP address, which is what I'm, currently hovering on, the public IP address, and then the tooling websites would come on. So we confirm distribution by using this command sudo tail, and the essence of this command is to, whilst we have the load balancer, whilst we are connected to the load balancer instance in our local machine, we are also connected, because I use VS Code at the time, so we also have to connect to the two web servers. All right, so the idea is, once you put up this IP address in the browser, you check, you load it, and then you use this command. I use this command and check the output from the load, from the web servers, to check um, uh, how do I put this now, to check in real time, that's the word, to check in real time which of the servers is receiving the traffic. Because as you refresh the tooling website, the web server, either of the web servers gets the traffic. So the what's it called, the terminal, for me, the terminal was open at the time. I refreshed the tooling website, checked. You'd notice that the web server, either web server 1 or web server 2, gets the traffic immediately, and you can identify that, or you can be sure of that by tracing the time the traffic gets into the web server. All right, and so for this DNS resolution, it's not exactly compulsory, but very optional, and the idea is just to okay, I'll just read from here first. Editing IP addresses across configs, it can be very, very stressful, which is very true. Having to access the internet with different IP addresses at every point in time can be stressful. It's just like saying, okay, you want to access Google now, and you need to know the address. It can be very stressful. You want to access like a football website. For someone like me, I visit work on a lot. It's a football website. I'm not sure. Even sometimes I even struggle with the name. Sometimes if I want to type from my head, and that's why DNS is actually very, very important. So the idea is to the idea is to configure a name to replace the IP address, such that if you call and if you look at it, okay, I'm just going to use my my cursor to over on this. So doing this in your local machine, it would produce, or it would give you the tooling website page in how do I explain this now? It will give you the tooling website page in a code format. Let me just say it that way. That's if you use this from your terminal. All right, so you just configure it from your etc/host file, and then you use the IP address, configure the web server, by the name web server 1, for the second one, web server 2, you configure, and then you call in your local machine. All right, and when you call, it gives you the tooling website in the code format. So yeah, Apache balancing methods by traffic, distribute loads according to traffic, by business, by request, by heartbeat, and yeah. So just to speak on the major key takeaways, Apache can act as a fully functional software load balancer using mode _proxy_balancer. Load balancing improves availability, scalability, security, performance for growing application. Horizontal scaling, more servers, and vertical scaling, more CPU are the two levers for handling growth. That's it from my end. Thank you so much for listening. I'll just wrap it up here.
So this diagram, from a stakeholder perspective, I do not know whether it is because of my skill, or maybe I'm not seeing the lines clearly. I'm not sure what the lines are communicating. on this diagram, I can see that the client is talking to the load balancer, and I can see another diagram of the load balancer to another line of the load balancer to the web servers. I can see another line of the web server 1 to the DB server. And
Okay.
I think that's all I can really make out of it. I don't know what the other two lines are doing on the other right hand side, or where they are coming from, or where they are going to from web server 2. The second question I'm asking is on the types of your slide on types of load balancing. I expected some explanation on each of the methods, even the 2-3 sentence explanation on these methods, because it is also a slide of value for team members and for stakeholders. So those are my two of them. Thank you.
Okay. Thank you. I'll just go back to the architecture. So I think I spoke a little bit on the fact that from the client's side, or as what you see as a client, which is like diagram on of maybe a laptop or something, what it suggests is the user, right, who is trying to access a particular platform or a software. Do you understand? That's the client. It's just like based on the client server software architecture, which is 3-tier architecture that we learned, from I think from some of the past projects that we did, right? So if you remember, we have the presentation layer, we have the application layer, and we have the data layer, right? So the presentation layer is basically about the client or the user. All right, the user interface, which can also be like, you can say it's the browser or your laptop that you are using to access a particular browser to get a particular content, from the internet. It could be Google, it could be whatever, just your laptop using it to access a particular content, right? Using the browser. It could be Chrome. We have different browsers, So when what's it called? This arrow, goes straight to a load balancer. That is, looking at this architecture, the way it's designed, the traffic or the request goes through a load balancer, right? So the load balancer in this context, all right, is designed to help route traffic effectively. All right, route traffic effectively to web servers. Now, the idea behind it, I already explained it, is so that traffic can be routed or distributed evenly amongst the web servers. But in this case, we have 2 web servers. Okay, so what the load balancer is doing here, perhaps maybe the diagram could have done a little bit of more justice. I get that point. Thank you for noting that. What the load balancer is doing here is routing traffic to web server A, routing traffic to web server C, web server 1, web server 2. The idea is so that the traffic is not just going to a particular web server, such that the web server becomes overworked and would invariably become unavailable because it has gotten to its limit, its resource limit. All right. I think to this point, I don't know if you understand me to this point. So, and behind the web servers, behind the web servers is the database or the DB server. All right. So, and that speaks to I think that's where what we can classify under the business layer. All right, which speaks about the business logic, or should I say? Okay, let me not say the business layer. It can be maybe referred to as the data layer. All right, and that's where the information. So when a client is trying to access an information from the internet, it goes through the load balancer. The load balancer, directs the traffic to the web server. The web server then takes that request to the database to inquire about what the client is asking or looking to get particularly. Do you understand? So the information that is required by the client is stored in the database. So it sends that request to the database. The database then returns the answer. Okay, the answer of that particular request. It returns it back. Getting that answer from the database returns it back to the client. All right. So for this NFS server, it's just a storage system basically, like from the name, network file system. All right. And the idea is, initially, before we started, the load balancer project, if you remember the former project we did before this one, the log directly was mounted on the NFS server, but at this point it was separated. The reason why it was separated is so that we can monitor the traffic that is coming into the web server. So I don't know if that answers your question, or if that sheds more light to the what's it called, the diagram or the image you can see on my screen.
Okay, yes, I get your image. So my point is, if you are presenting this to a stakeholder and the subject matter is just load balancer, it might as well stop at the web server 1, web server 2. Okay, by the time you introduce the DB server in your diagram, and then introduce the NFS server in your diagram, this diagram looks as if web server 1 is not talking to the NFS server. It also looks as if web server 2 has no business with the DB server. So that's the point I'm making about the diagram.
Okay.
I as a colleague understand what you are saying, because I've seen the other diagram, I've seen the full diagram. There as a stakeholder or as a non-technical person, the diagrams here, either you take out the DB server and the NFS server and stop at web server 1 and 2, which speaks properly to your topic of the load balancer.
Thank you, sir. So the first one, by traffic, we already know what traffic. Okay, let me not say we already know. It distributes the load according to traffic, which means a request. When you put up a request on the internet to get a particular content, all right. So it goes into the platform, it goes into the system as traffic, all right, and that's just what it speaks to, right? So the other one, which is purely by request count, weighted by load factor. If you remember, I'm trying to remember. I read something about it recently. When configuring the load balancer, so there is a way you configure the load balancer such that you configure the load balancer to route traffic to the servers based on the load, or based on how you want the load. You want the servers to carry the load, if I put it that way. So whether you want it to be evenly distributed, or you want a particular server to get more load than the other, so it's based on that form of request. I don't know if what I'm saying makes sense. So that's just the idea behind that. So by busyness from the word busy, so it just depends on which of the server is active. Sends the next request to whichever server has the fewest active requests. So sometimes servers can be less busy than the other ones. I don't know if that that word is maybe as acceptable within our context as engineers. So what I'm saying is that some servers can be busy more than other servers, right? So load balancer also can be configured or works in that manner, such that it looks out for servers that are less active or has less active requests, right? And so by heartbeat, uses live heartbeat data from servers to inform balancing decisions.
The diagram did not really explain that. Maybe if a server goes down, is there a way that another server can take its place generally, or what time frame is given that the server will be fixed or replaced or something like that? Thank you. Those are my questions and observation.
Okay, thank you for that question. It's all based on the infrastructure to begin with. Or let me first of all speak about the concept. I think you asked about the concept. I already spoke about it at length, but let me just say one or two on it again. The concept of load balancers, we understand from the word load balancer as user demand increases on a particular application or software, right? There is a need to be able to for that software to scale to meet up to the kind of request or traffic or demand at the moment or at the time, depending on whatever reasons, uh, you know, uh, whatever reasons is behind it. Now, the idea is this: when certain softwares are being designed, all right, of course, it is anticipated that at some point there'll be there will be spike in traffic, and at some point the traffic would go down. So there there was a time I read a little bit about Kubernetes. This is now a kind of like a leap, all right. We've not gotten there in our learning, but what I understand is at the point where a software is being designed, there is the proactiveness or foresight to say, let the system be designed like this in such a way that when there is spike in traffic, there is an automatic um, there's an automatic response from the server or from the load balancer to automatically spin up another server. So it can be done manually, right? But of course, we know how tedious that can be. But then it's the automation part that makes it very, very efficient, which is just spinning up the server, which has the capacity to automatically receive requests, and then of course, inquire, goes to the database, gets it, and then sends the response back to the client. What I'm saying is, I think, in my opinion, it has to do with the Kubernetes technology. So I might be wrong, but that's my answer or my response to it at this point. So, and thank you for also mentioning the point that the diagram doesn't necessarily, doesn't not even necessarily does not explain how a server or a new server you know, can be designed automatically when there is a spike in traffic.